Hello, sleepy thinkers, and welcome to Sleepy Science Teller, a quiet place where science meets calm reflection. Tonight, we will wander gently into the mysteries of the universe and wonder together what lies inside a wormhole. A wormhole is one of the most fascinating ideas in physics. It is imagined as a tunnel hidden within the fabric of space and time, a passage that could connect two distant places in the universe, or perhaps two different moments in time, though we have never seen one. The idea itself is enough to inspire wonder, curiosity, and perhaps a little dreaming before we float deeper into this thought. Would you share something with me? Type in the comments where in the world you are listening from and what time it is for you right now. It's always beautiful to see how this journey connects us across the globe. And while you're here, if you find comfort in these calm explorations, please gently press the like button and consider subscribing so that you can drift with us again and again. Imagine, dear listener, you're lying quietly under the night sky. The stars are scattered above you, like tiny sparks on a dark canvas. And in this silence, a question rises gently in the mind. Is there a secret path between those distant points of light? This question is at the very heart of the idea of a wormhole. A wormhole is like a hidden tunnel connecting two places in the universe. It is not just a passage through space, but through the very fabric of reality itself. When scientists speak of wormholes, they describe them as shortcuts, as if the universe folded itself like a sheet of paper, bringing two faraway points together so that a traveler could step across in an instant. To picture this more softly, imagine a leaf resting in your hand. If you place an ant on one edge of the leaf, the ant must crawl all the way around the veins and curves to reach the other side. But if you gently fold the leaf so the two edges touch, the ant could simply walk across the bridge, skipping the long journey altogether. That fold is a way to imagine the idea of a wormhole. In our universe, space and time themselves can bend. Gravity curves them around stars, planets, and galaxies, and in the mathematics of these curves, there are shapes that seem to allow shortcuts. Wormholes are these shapes. They are not doors we have seen, but dreams drawn from equations, whispers of possibility, hidden in the laws of physics. The idea of a wormhole is powerful because it combines two deep human desires: the wish to explore the vast cosmos, and the hope that there may be secret, magical ways to travel faster than light. When we look at galaxies millions of light years away, the thought of crossing the distance in a blink fills the mind with wonder and the heart with a quiet longing. But wormholes are not only science, they are also stories. Science fiction writers have long imagined them as gateways between worlds or bridges between moments in time. In these tales, a spaceship enters the swirling mouth of a wormhole and emerges somewhere new, perhaps near another star or in another age. Though these are only stories, they help us dream about what might be possible. At its core, the idea of a wormhole is a marriage of imagination and physics. It is a reminder that the universe may hold pathways beyond our current reach, that reality itself may be more flexible, more mysterious than it first appears. Let us drift deeper now into the reasons why wormholes capture the imagination. The universe is vast, almost unimaginably so. When we gaze through telescopes, we see galaxies scattered across billions of light years, each one filled with billions of stars, and each star perhaps surrounded by planets. To travel across such distances using ordinary means would take far longer than the age of the universe itself. Light, the fastest thing we know, moves at nearly 300,000 kilometers per second, yet even light would take over 100,000 years just to cross our own Milky Way galaxy. And to reach the next nearest galaxy, Andromeda, light would need more than 2 million years. For human beings who measure life in decades, such scales feel overwhelming. So we imagine shortcuts, hidden bridges that fold the universe, so that a journey of millions of years might become a gentle step. The idea of a wormhole is a soothing answer to the question of distance. It suggests that space may not be as rigid as it seems, that there may be secret passages, like hidden tunnels in a mountain, leading us to places we could otherwise never reach. But there is more. The idea of a wormhole also speaks to our curiosity about time. For if such a tunnel can connect 2 points in space, could it also connect 2 points in time? Could one doorway lead to the past and the other to the future? The thought alone softens the boundaries of what we think possible. Throughout history, humans have told stories of hidden doors, fairy rings that lead to other worlds, secret wardrobes that open into magical lands, caves that echo with timeless whispers. The wormhole is the scientific echo of those myths, a modern symbol of secret doors in reality. Even if we never build one, the idea itself is a comfort. It reminds us that the universe is not closed to wonder, that even in the cold silence of space, there may be surprises waiting to be imagined. In this way, wormholes are both science and poetry. They are equations on a chalkboard and dreams whispered under the stars, bridges not only across galaxies, but across the human mind, linking reason with wonder and knowledge with imagination. Now, let's take a slow, imaginary journey, as if we are traveling through the idea of a wormhole itself. Close your eyes and picture the night sky. The stars above are endless, each one shining from a great distance. And yet, in this dreamlike space, you feel a quiet pull, a gentle invitation, as if the stars are not as far as they seem. Before you, the fabric of space begins to ripple like the surface of a still pond. Touched by a single drop, the ripple deepens, forming a tunnel, a curve within the night. It is not frightening, but calm, soft, and glowing faintly with starlight. You step closer and see that one end of the tunnel opens where you stand, while the other flickers with the light of another world. This is the heart of the idea of a wormhole. It is not a physical tunnel we can enter today, but a symbol, a shape drawn by the laws of physics, a possibility that whispers to us that reality may hold secret folds. As you drift through this imagined tunnel, you realize the idea of a wormhole is not only about travel, it is about connection. It is about bridging what seems too far apart, uniting 2 points that were thought to be forever separate. And as you gently emerge from the other side of this dreamlike path, you understand that wormholes are less about where they lead and more about what they reveal, that the universe is full of hidden possibilities, waiting quietly in its depths. So the idea of a wormhole is not just an escape from distance. It is a reminder that the universe is mysterious and alive with wonder, that even the impossible can find a place in our imagination, and that within the quiet fabric of space-time, there may always be room for dreams. Let us drift now into the 1930s a time when the mysteries of the universe were just beginning to unfold. Albert Einstein, the gentle thinker with wild hair and deep eyes, was shaping our understanding of space and time. Beside him was Nathan Rosen, a mathematician with a gift for clarity. Together, they would imagine something extraordinary, something we now call the Einstein-Rosen bridge. At the heart of their idea was Einstein's theory of general relativity. This theory tells us that space and time are not rigid. They're like a vast, flexible fabric, bending and curving around the weight of stars and planets. Gravity is nothing more than the shape of this fabric. A planet orbits a star because the star bends space around it, like a ball sinking into a soft cushion. Einstein and Rosen studied these curves carefully, especially around the strangest objects known at the time, black holes. Black holes are places where gravity becomes so strong that not even light can escape. To Einstein and Rosen, the mathematics of black holes held a secret. As they solved equations, they discovered that every black hole solution seemed to hide another region mirrored on the other side. In the math, it was as if two separate universes were connected at the center of a black hole. This connection, this tunnel in the equations, became known as a bridge, the Einstein-Rosen bridge. It was not a bridge of stone or steel, but a bridge woven out of the fabric of space-time itself. On one side, a black hole. On the other side, what appeared like the mirror of that hole. And in between, a tunnel, fleeting, fragile, but mathematically possible. For the first time, physics had imagined a passageway, a tunnel that could connect two regions of space, perhaps even two universes. It was like finding a hidden doorway, not in a forest or a mountain, but in the laws of reality itself. Einstein himself was cautious. He did not think such bridges would be stable. He suspected they would collapse instantly, sealing themselves before anything could pass through. But still, the thought had been planted. A new idea had entered the dream of science. The Einstein-Rosen bridge was the first true wormhole, born not from stories, but from equations. It was a glimpse of what might be hidden deep within the mathematics of the cosmos. To understand the Einstein-Rosen bridge more softly, let us imagine space-time as a sheet of fabric again. When a heavy object rests on it, the sheet bends, forming a deep curve. This curve is like the pull of gravity. Now imagine not one curve, but two heavy objects bending the fabric in opposite directions. If we push these curves together, they may meet at their deepest points. And when they meet, a tunnel forms. One end leads into one curve, the other out of the other. This is the essence of the Einstein-Rosen bridge. It is not so different from imagining two wells in ground, each dug from a different side, meeting in the middle to form a tunnel. But here, instead of dirt and rock, the tunnel is carved through space-time itself. Let us make it gentler still with a story. Imagine you are walking in a meadow, and before you stands a mountain. To cross, you must climb, step after step, until you reach the summit, and descend again. It is a long journey. But now imagine that hidden within the mountain is a secret tunnel, a dark, cool passage that carries you quickly to the other side. The Einstein-Rosen bridge was like this hidden tunnel, not through stone, but through reality itself. And yet, there was a difficulty. Einstein and Rosen realized that this tunnel could not stay open. It would pinch shut too quickly, faster than even a ray of light could pass through. It was like a door that slammed closed the instant it was discovered. Still, the idea was there. The mathematics whispered that such tunnels could exist, and this whisper has echoed through science ever since. The Einstein-Rosen bridge gave birth to the modern dream of wormholes. It showed us that the laws of physics are not as rigid as we once thought, that hidden inside black holes, or perhaps far beyond them, there might be connections between worlds, even if they collapse too quickly, even if they remain forever beyond our reach. The bridge itself is a symbol, a reminder that reality is stranger, softer, and more mysterious than it first appears. Let us drift now into the legacy of this idea. The Einstein-Rosen bridge did not end in the 1930s. It became the seed of countless explorations in both science and imagination. Physicists wondered, could such bridges ever be stabilized? Could exotic matter, with unusual energy, hold them open long enough for travel? The question has never been fully answered, but it continues to inspire research today. Science fiction embraced the bridge eagerly. Stories of wormholes filled books and films, where travelers stepped into one mouth and emerged light years away, or centuries apart. In these tales, the Einstein-Rosen bridge became a gateway of dreams. Even today, when we picture a wormhole, we often imagine it as a tunnel of light, a swirling passage that stretches space into a glowing corridor. This image, though fanciful, is a descent of that first idea, born in Einstein's equations. But the bridge has also shaped serious science. The study of quantum physics, black holes, and cosmology all touch upon the possibility of connections in space-time. The Einstein-Rosen bridge continues to whisper to scientists that the universe may hold structures we have yet to see. And there is something soothing in this thought, that even as we map the stars, even as we launch telescopes into the void, the deepest mysteries remain, hidden not in distant galaxies, but in the quiet mathematics of reality itself. The Einstein-Rosen bridge reminds us that the universe is not flat and simple. It is curved, folded, and filled with surprises. That a black hole, once thought to be only a devouring void, may also be a gateway, a bridge, at least in theory. And so, as you drift with this thought, picture again the night sky, the stars glowing gently above, and between them, unseen bridges, invisible threads of connection, silent tunnels in the fabric of reality. Whether or not we ever walk them, the idea itself is enough to bring both wonder and calm. The Einstein-Rosen bridge was not just an equation, it was a doorway in thought, a doorway that remains open in the human imagination. Imagine, dear listener, that the universe is not empty, not a silent void, but something soft, something woven, like a great invisible fabric, stretching across all that exists. This fabric is what scientists call space-time. It is the stage upon which every star shines, every planet turns, every comet drifts, and every thought, every heartbeat takes place. When Einstein first described it, he asked us to think of space and time, not as separate things, but as one single interwoven cloth. Space gives us directions to move, left and right, forward and back, up and down, and time gives us the rhythm in which movement happens. Together, they form a four-dimensional fabric, space-time. Now, let us imagine this fabric as something we can see. Picture a great sheet stretched gently across the cosmos. It is invisible, but it holds everything in place. The planets, the stars, the galaxies. all rest upon it, all move along its gentle curves. When a heavy object appears on the sheet, it presses downward, bending the fabric around it. This bending is what we call gravity, not a mysterious pulling force, but simply the way objects move when the fabric beneath them is curved. If you place a marble on a stretched cloth, it will roll toward a heavier ball that sits in the middle, not because the ball pulls it directly, but because the cloth itself is curved, and the marble must follow that curve. So it is with planets and stars. The Earth does not cling to the sun by a rope. It simply moves along the curve of space-time that the sun creates around it. This picture of the universe as a fabric changed everything we knew about reality. It replaced the old idea of space as a blank stage with something dynamic, living, responsive. Space-time bends, ripples, and even vibrates like water, carrying the echoes of events across the cosmos. When we see this fabric in our mind's eye, we begin to understand why wormholes might exist. For if the fabric can bend, perhaps it can fold, and if it can fold, two distant points may touch, revealing a hidden bridge between them. But before we reach wormholes, we must linger here and feel the softness of this idea that all of existence, from the tiniest grain of dust to the grandest galaxy cluster, is carried upon the same silent weave. Let us wander deeper into stories that reveal the fabric of space-time. Picture a spacecraft floating between the stars. To the astronauts inside, it feels as though they are weightless, but in truth, they are simply following the curves of space-time. Their path is not straight. It is guided by the invisible bending of the universe. This bending explains why the moon orbits the Earth, why the planets circle the sun, why galaxies swirl in grand spirals. Each motion is not random, but a graceful response to the shape of the cosmic cloth. And this fabric is not still. It can ripple. When two black holes collide, they send waves through space-time itself, like stones dropped into a pond. These waves, called gravitational waves, travel across the universe, so faint that only the most delicate instruments can hear them. But when we do hear them, it is as though the fabric itself whispers of distant cataclysms from billions of years ago. Let us pause for a gentle story. Long ago, people thought gravity was a pulling hand, an invisible thread tying us to the earth. But now we see it is the Earth's mass bending the fabric around it, and our bodies following that curve. We are not pulled down. We are simply walking upon the folds of space-time, each step pressing gently into the universal cloth. Think also of light, the fastest travel we know. Even light does not escape the fabric's influence. When it passes near a star, its path bends, curving along the warped space-time. Astronomers call this gravitational lensing, and it allows us to see galaxies magnified and multiplied by the bending of the fabric itself. So, the fabric is more than a metaphor. It is not just an image in our minds. It is a living truth, woven into every corner of reality. It bends around matter. It carries waves of gravity. It even determines how light moves and how time itself flows. This last thought is perhaps the most wondrous, for time, too, is shaped by the fabric. Where the fabric is stretched by strong gravity, time flows more slowly. A clock near a black hole ticks more gently than a clock far away in open space. This is not imagination. It is a truth tested again and again by satellites, by experiments, by the very GPS in your phone. The fabric of space-time is the quiet stage, but also the hidden actor. It shapes, guides, and whispers through every motion of the universe. Now, dear listener, let us take a gentle journey through this fabric of space-time itself. Close your eyes and picture yourself floating in the stillness of the cosmos. The stars around you shine softly, like lanterns in the dark. As you drift, you begin to see the invisible. The space around each star is curved, like circles pressed into a soft sheet. Galaxies bend the fabric in vast spirals, and black holes press so deeply that their curves become endless wells. You reach out your hand, and though you cannot touch the fabric, you feel its presence. Every step, every motion follows its lines. You are not separate from it. You are part of it. And then something wondrous happens. The fabric begins to ripple. A wave moves beneath you, gentle, like the rise and fall of an ocean tide. It is the echo of two massive stars colliding billions of years ago. Yet here you are, feeling the soft rhythm carried across the universe. This is the truth of the cosmic cloth. It is not distant. It is here now, flowing quietly beneath your life. It holds the earth as it circles the sun. It holds your body as you rest upon the planet. It carries your breath, your heartbeat, upon its endless weave. And perhaps, in this gentle awareness, you see why wormholes are possible. For the fabric can ripple. If it can stretch and bend, then maybe, just maybe, it can fold. Two faraway points press gently together, revealing a secret bridge. The idea of wormholes is born from this fabric. It is a fabric's deepest whisper. That reality is not rigid, but soft, alive, and full of hidden paths. So let yourself rest with this thought that beneath the stars, beneath the galaxies, there is a quiet, invisible fabric holding all things, binding all journeys, and perhaps, if folded, revealing hidden doors. Imagine, dear listener, that you are standing at the mouth of a glowing tunnel, a wormhole, softly shimmering against the fabric of space-time. It hums quietly, as if whispering of distant stars, inviting you to step forward and discover where it leads. But here is the question. Would you be able to pass through, or would the tunnel collapse the moment you touched it? This is the difference between traversable and non-traversable wormholes. A traversable wormhole is one that stays open long enough, stable and safe enough, for light or even a traveler to cross from one end to the other. It would be a cosmic bridge, a true passageway between places, perhaps even between times. But a non-traversable wormhole is like a doorway that slams shut the moment you try to walk through it. The tunnel collapses instantly, crushing down upon itself, allowing no light, no matter, no traveler to cross. When Einstein and Rosen first described wormholes, they imagined what we now call non-traversable wormholes. Their bridge existed in the mathematics, but only for a fleeting instant. It pinched closed too quickly, before even the fastest ray of light could pass through. Later, physicists wondered, what if there were a way to hold a wormhole open? What if some strange kind of matter could keep the tunnel stable? Such wormholes, in theory, could be traversable. This idea is thrilling, for it suggests that one could step into a wormhole and emerge on the other side of the universe, or perhaps in another time altogether. But there is also caution here, for the universe does not give up its secrets easily. The equations allow the dream, but the reality may be far less forgiving. Still, as we drift together tonight, let us explore gently what makes one wormhole traversable and another not. Let us imagine wormholes as doorways in the fabric of space-time. A non-traversable wormhole is like a door carved into water. For a moment, you may see the opening, but the ripples close it instantly, erasing the passage before you can step through. This is because space-time is not rigid. The moment a tunnel forms, gravity itself pulls upon it, collapsing the opening into nothingness. The immense pressure of the universe does not allow the doorway to remain. Black holes, in particular, are thought to hide such non-traversable bridges. Deep in their centers, the mathematics suggests tunnels that connect to other regions, but the crushing gravity and the tidal forces that stretch and tear would destroy anything that tried to enter. These wormholes are like shadows of possibility. Beautiful, yes, but unreachable. Traversable wormholes, on the other hand, would need something more. They would need a force to resist collapse, to keep the tunnel open against the pull of gravity. Here, physicists speak of exotic matter, not ordinary matter, not stars, planets, or dust, but something stranger with negative energy that pushes outward instead of pulling inward. If such exotic matter exists, it could act like scaffolding, propping open the tunnel, keeping the passage stable, so that light or even a traveler could move through safely. But exotic matter remains a mystery. We do not know if it exists in the right form, or if it could ever be gathered in enough quantity. It is like dreaming of a bridge without yet knowing what materials could build it. So for now, the traversable wormhole lives only in equations and in the imagination. But let us pause, dear listener, and picture the difference more gently. A non-traversable wormhole is like a dream that fades when you wake. It is a glimpse of possibility, gone before you can touch it. A traversable wormhole is like a door that stays open, a glowing archway leading into the unknown. It invites exploration. It invites wonder. And though we may not yet walk through, the thought itself is enough to soothe the mind and fill the heart with quiet awe. Now, let us take an imagined journey through a traversable wormhole. You stand before the mouth of the tunnel. It shimmers softly, like a veil of light. The air around you is calm, silent, except for a faint hum, like the universe breathing. You step forward, and the light surrounds you. It is not harsh, not overwhelming, but soft, gentle, and warm. You feel no weight, as though you are drifting through a river of stars. The walls of the tunnel ripple faintly, patterns of galaxies glowing like threads in a tapestry. Time seems to stretch and yet collapse. Moments flow together, and distance melts into silence. And then you emerge. Perhaps you find yourself orbiting a distant star, its light new to your eyes, its planets waiting with secrets unknown. Or perhaps you step into another time, where the stars are younger or older, where the universe itself feels different. This dream is what makes a traversable wormhole so captivating. It is not only about science, it is about possibility. It is about the gentle hope that somewhere in the fold of reality, there may be doorways waiting, leading us to places we have never seen. But in contrast, let us also imagine the non-traversable wormhole. You see the tunnel open, but as you reach for it, it collapses into darkness. The shimmering veil pinches shut, leaving only the silence of space. It was a promise that could not be kept, and so the two kinds of wormholes stand as symbols. One, the fleeting, unreachable doorway. The other, the enduring bridge of dreams. Science, for now, tells us that non-traversable wormholes are real in theory, but traversable wormholes require ingredients we cannot yet touch. Still, both invite wonder. Both remind us that SpaceTime is alive with possibilities, and both whisper to us that the universe holds secrets beyond imagination. So let your thoughts drift now between the two kinds of tunnels, the ones that collapse and the ones that endure, the fleeting shadows and the lasting dreams. In this gentle contrast, we see not only the science, but the poetry of the cosmos. Close your eyes for a moment and imagine a material unlike anything you have ever touched. Not stone, not metal, not air nor fire, but something stranger, softer, yet more powerful. A kind of matter that bends the rules of the universe itself. This is what physicists call exotic matter. It is not exotic because it comes from a faraway land or from another planet. It is exotic because its very nature defies the expectations that ordinary matter follows. Ordinary matter is everything you see around you, the chair you rest upon, the air you breathe, the stars that burn in the night sky. All of it follows the rules of mass and gravity. Matter has energy, it has weight, and gravity pulls it inward, always inward. But exotic matter would behave in the opposite way. Instead of being pulled inward, it would push outward. Instead of possessing positive energy, it could have negative energy. It is this negative energy that makes exotic matter so important to the dream of traversable wormholes. You see, wormholes want to collapse. Their tunnels are unstable, and gravity is forever trying to pinch them shut. But if one could line the walls of a wormhole with exotic matter, its negative energy could act like scaffolding. It would push outward, keeping the tunnel open, holding the cosmic doorway wide, so that light, and perhaps even a traveler, could pass safely through. This is why physicists dream of exotic matter. Without it, wormholes remain fleeting shadows, non-traversable, collapsing too quickly to use. With it, they could become stable, true bridges across the stars. But what is exotic matter, really? Is it only a mathematical curiosity? Or could it exist somewhere hidden in the folds of reality? To answer this, we must explore the strange realms where theory and imagination meet. Exotic matter is not something we can hold in our hands, but there are whispers of it, hints in the mathematics of quantum theory, and shadows in the experiments of physics. One of these whispers comes from the Casimir effect. Imagine placing two metal plates very close together, so close that only certain wavelengths of energy can exist in the gap between them. Quantum physics tells us that empty space is never truly empty. It is filled with tiny fluctuations, particles and antiparticles, flickering into existence and vanishing again. Between the plates, some of these fluctuations cannot fit, and so the energy there is less than the energy outside. This creates a pressure that pushes the plates together. In a way, this experiment reveals a kind of negative energy. It is not exotic matter itself, but it shows us that the universe can behave in ways that ordinary intuition cannot explain. Physicists wonder, could such effects on a much larger scale provide the negative energy needed to keep a wormhole open? Another glimpse comes from the study of dark energy. This mysterious force is thought to be pushing the universe apart, causing its expansion to accelerate. Dark energy behaves unlike ordinary matter. It resists gravity. It pushes outward endlessly. Could dark energy be related to exotic matter? We do not yet know, but the idea is tempting. For if the universe is filled with a substance that resists collapse, then perhaps wormholes could be shaped by it. Still, there are challenges. The quantities required would be immense, far beyond anything we can imagine collecting. And yet, the fact that negative energy is even possible keeps the door of imagination open. So, dear listener, exotic matter is not fantasy. It is not magic. It is an extension of the same physics that governs the stars and the atoms. It is simply stranger, and it may hold the key to unlocking the tunnels of the cosmos. Let us drift now into the dream of what exotic matter might allow. Picture a wormhole, a tunnel woven through the fabric of SpaceTime. Without exotic matter, the tunnel begins to collapse, its walls folding inward, like soft fabric crumpling in the hand of gravity. But with exotic matter, the walls are braced outward, like a tent supported by poles, or a tunnel shored up with beams. The negative energy pushes back, balancing the inward pull. The tunnel holds. The doorway remains open. Now imagine travelers stepping into this passage. They are not crushed. They are not lost. They pass gently through, guided by the strange force of exotic matter, emerging light years away, as though the distance had melted into nothing. This dream feels so close, and yet so far, for we do not know if exotic matter can exist in the right form, or if the universe even allows it to be gathered. It may remain forever out of reach, and yet there's a kind of beauty in that uncertainty. For exotic matter, whether real or not, expands our imagination. It teaches us that the universe is not confined to the familiar, that beyond the stars, beyond the galaxies, there may exist rules and substances we have only begun to glimpse. Perhaps one day, when our science is older and our reach into the cosmos is deeper, we will find ways to touch the exotic, to shape it, to use it to build bridges across the stars. Until then, it lives in our equations and in our dreams. And sometimes that is enough, for in the quiet of the night, as we drift into rest, it soothes us to know that the universe holds mysteries so deep that even the most brilliant minds can only whisper of them. So let your thoughts float gently now on the possibility of exotic matter, stranger than stone, stranger than light, perhaps stranger than anything we can yet imagine. And remember, it is in the strange that wonder often lives. Time, it flows gently like a river, carrying us forward second by second, from morning into night, from today into tomorrow. We cannot stop it. We cannot step backward, at least not in our everyday lives. But what if there were doorways in the universe that bent the river of time? What if wormholes could allow us not only to travel across space, but also across time? This is where science and dreams begin to intertwine. You see, time is not separate from space. Einstein taught us that space and time are woven together into a single fabric, space-time. And if you bend that fabric in just the right way, you may bend time along with it. Imagine two mouths of a wormhole. If one mouth stays still, while the other is carried near the speed of light, or placed in the grip of immense gravity, then time will tick differently for each end. This is not fantasy. It is the truth of relativity. A clock near a massive star runs slower than one far away. A clock moving close to light speed ticks more slowly than one at rest. So if one mouth of a wormhole is moved in such a way, it will become younger than the other. Step through the tunnel, and you could emerge in a different time, perhaps into the future, perhaps even into the past. This idea is breathtaking, for it suggests that wormholes could be not only bridges across the cosmos, but also bridges across the river time itself. And yet, the possibility raises as many questions as it answers. Could time really be rewound? Or would the universe guard its secrets too carefully? Tonight, let us drift through these possibilities, exploring gently the hopes, the paradoxes, and the quiet wonder of traveling through time. If wormholes could allow us to step through time, what would that mean? Imagine you walk into a wormhole today and emerge yesterday. You stand in your own home, but everything is just as it was the day before. What could you do? What would you change? Here lies the mystery. Physicists call these puzzles time travel paradoxes. The most famous is the grandfather paradox. If you went back and changed something in the past, like preventing your own grandfather from meeting your grandmother, would you erase your own existence? And if you no longer exist, how could you have traveled back in time at all? This loop of logic seems to defy reason. Some scientists suggest that perhaps the universe does not allow such contradictions, that events are fixed in a way that prevents paradoxes from happening. If you travel back in time, you might still be free to act, but whatever you did would already be part of history. Others imagine parallel universes. In this view, when you step into the past and make a change, you do not alter your own timeline. Instead, you create a new branch, a new universe where events unfold differently. Your own timeline remains unchanged, but elsewhere a new reality begins. Both possibilities are fascinating. Both soothe the mind with gentle mystery. And then there's the question of the future. Traveling forward is easier to imagine. In fact, relativity already tells us it can happen. Move at near light speed, and time slows down for you, while the rest of the universe continues at its normal pace. When you return, centuries may have passed, though only moments have passed for you. In this sense, the universe already allows a kind of time travel to the future, a slow one-way ticket carved by the laws of physics. But the dream of stepping through a wormhole and instantly arriving in another era, that remains a story written in the language of possibility. Still, dear listener, isn't it soothing to know that time may not be as rigid as it seems? That the universe itself whispers of flexibility, of pathways hidden in its folds. Let us imagine time differently, not as a river that flows in one direction, but as a landscape. The mountains of yesterday rise behind us, the valleys of tomorrow stretch ahead, and we, standing in the present, are like travelers walking gently across this terrain. A wormhole, then, could be a tunnel through the mountains of time, a shortcut from one valley to another, a doorway carved across the landscape of moments. Some physicists describe time as a block, where past, present, and future all exist together, like pages in a book. We only turn one page at a time, but the others are still there, waiting. If this is true, then perhaps wormholes could allow us to skip ahead, or revisit a page already turned. The thought fills the heart with wonder, and also with humility. For time is not something we command. It is something we drift within something we listen to like the slow rhythm of a heartbeat. And yet, in the soft silence of imagination, it feels possible. Perhaps the universe is vast enough, generous enough to allow such journeys, and perhaps not. But here is the gentle truth. Even if time travel through wormholes remains impossible, the dream itself enriches us. It teaches us to see time not only as something that slips away, but as something precious, mysterious, and vast. It reminds us that every moment is unique. Every breath, every glance, every quiet second is a gift that can never be repeated. So whether wormholes someday open doorways through time, or whether they remain forever in a realm of dreams, they invite us to live more deeply, to cherish the present, while still marveling at the possibility of what could be. So rest gently now, with thoughts of time as a landscape, and wormholes as secret tunnels within it. Perhaps you will dream tonight of stepping into one and waking in another age. For in the calm embrace of sleep, even time itself may feel like a place we can wander. Close your eyes, dear listener, and imagine floating high above the earth, looking down upon oceans, mountains, and clouds. You feel the gentle pull, a force that holds you close to this planet, the same force that keeps the moon circling and the stars dancing in their cosmic waltz. This force is gravity, invisible, silent, yet ever present. It binds the universe together. It sculpts the paths of planets and galaxies, and it whispers softly through the fabric of space-time itself. When we think of wormholes, gravity is at the heart of their story. For wormholes are not made of stone or wood or metal. They are carved out of gravity's influence. Einstein's great insight was that gravity is not just a pull, not just an invisible tether between objects. Instead, gravity is the bending of space-time itself, like a sheet of fabric sagging under weight. The stars and planets press into this fabric, creating curves, valleys, and pathways that other objects follow. A wormhole, then, is one of gravity's most mysterious sculptures. It is as though gravity has not only bent the fabric, but folded it in such a way that two distant regions touch. Picture folding a piece of paper, bringing 2 points together, and piercing a tunnel between them. That is the essence of a wormhole. But gravity is not only the creator of wormholes, it is also their destroyer. For the same immense force that shapes them also tries to close them. Without balance, without resistance, the tunnel collapses under gravity's weight. This is why exotic matter is so important. For while gravity pulls inward, exotic matter must push outward so that the wormhole may stay open. And so, gravity's role is both gentle and fierce. It is the architect of the possibility, and also the guardian of its secrecy. As we drift further, let us listen more closely to the quiet voice of gravity and its role in these cosmic doorways. Let us imagine space-time as a vast, dark ocean. In this ocean, stars and planets are like ships resting upon its surface. A small ship dips only a little. A great ship presses deeply into the waves, and any small vessel that drifts nearby will naturally slide toward the dip. This is how gravity works. The sun presses deeply into space-time, and the Earth follows its curve, forever circling in orbit. But now imagine that instead of a single dip, gravity presses space-time so intensely that it folds inward, forming a tunnel. This is the vision of a wormhole. Black holes show us gravity at its most extreme. They are regions where space-time curves infinitely, so steeply that nothing can escape. inside their depths. Mathematics hints at tunnels, hidden pathways that could connect to elsewhere. But gravity alone is not kind. Inside a black hole, the tidal forces are immense. If you were to drift too close, your body would be stretched atom by atom in what scientists call spaghettification. The same gravity that sculpts the wormhole also tears apart anything that dares to enter. And yet, there is wonder here, for it means that gravity is more than a simple force. It is the shaper of time, the sculptor of the cosmos. Without gravity, there would be no stars, no galaxies, no chance of wormholes at all. Physicists often dream of balancing gravity, harnessing it so that the tunnel of a wormhole does not collapse. To do this, one must imagine a cosmic tug-of-war. On one side, gravity pulling inward. On the other, exotic matter pushing outward. If the two forces balance perfectly, the wormhole could remain stable, a lasting doorway through the folds of the universe. But achieving this balance is beyond our reach. Gravity is immense, and exotic matter remains only a whisper of theory. Still, when we close our eyes, we can imagine it. A tunnel glowing softly in the dark ocean of space-time, held open by a delicate balance of forces, the silent sculptor and the mysterious counterforce, together holding the key to the stars. Gravity is patient. It does not rush. It simply pulls, softly and endlessly. It guides planets into orbits, stars into galaxies, and galaxies into clusters that span the heavens. And so it is with wormholes. Gravity creates the conditions for their existence, folding and curving the cosmic fabric into possibilities that stretch the imagination. But gravity also reminds us of limits. It says, yes, doorways may exist, but they are fragile. Without balance, they close. Without care, they collapse. In this way, gravity becomes both a poet and a guardian. It writes the verses of possibility, but it also guards the doors, revealing them only in mathematics and imagination. Think of gravity as the heartbeat of the universe. Quiet, steady, eternal. Every star you see tonight, every step you take on Earth, is guided by the same rhythm. And when we dream of wormholes, we are really dreaming of gravity's hidden depths, of its ability not only to hold us here, but to open passages beyond. Perhaps one day we will learn to work with gravity, to balance it with exotic matter, to carve stable tunnels in the cosmic fabric, and then the universe may open in ways we cannot yet imagine. Until then, we rest in the knowledge that gravity is always with us, holding us close to Earth, keeping the stars in place, and whispering quietly of wonders still unseen. So let yourself drift now, with thoughts of gravity as a sculptor, a guardian, a patient artist of the cosmos. For every step we take into the unknown, every wormhole we dream of crossing, begins with gravity's gentle pull. Imagine, dear listener, a star massive and bright, burning for millions of years. Then one day its fuel is gone, the fire that once held it up fades. The star collapses inward under its own weight, falling, endlessly falling, until nothing can resist its pull. What is left is a black hole, a region so dense, so powerful, that even light cannot escape. It is not merely dark. It is a place where the very fabric of space and time is pulled into silence. Black holes are not just voids. They are sculptors of reality. They curve space-time so steeply that all paths bend inward. They are the most extreme expression of gravity's quiet power. And yet, within their mathematics, lies something even stranger. For black holes do not simply swallow. They also hint at tunnels, doorways through space-time that may connect to distant places. These doorways are wormholes. At least that is what the equations suggest. When Einstein and Rosen first wrote of them, they imagined wormholes as bridges hidden inside black holes. They called them Einstein-Rosen bridges. In theory, the center of a black hole could be linked to another region of space, perhaps even to another universe. But the tunnel is unstable. The same gravity that creates it crushes it shut before anything can pass through. And so, black holes and wormholes are bound together. Two faces of the same mystery. One is a destroyer, the other the dream of a passage. As we rest together tonight, let us wander deeper into this relationship between darkness and possibility. Let us think of black holes as shadows and wormholes as bridges. The shadow consumes all light. Anything that strays too close is lost. It is a boundary called the event horizon. Once crossed, there is no return. But within the mathematics of general relativity, beyond this shadow lies a suggestion, a hidden bridge. The equations allow for the possibility that the inside of a black hole could connect to elsewhere. This is why some physicists once wondered if every black hole might secretly be a doorway, a tunnel leading not only across space, but perhaps to another time, or another universe entirely. But the truth is harsher. The wormholes inside black holes are non-traversable. They collapse instantly. Their passageways close before even a single photon can cross. To step into a black hole is not to travel through a bridge. It is to be torn apart by gravity's endless grip. And yet, the link between black holes and wormholes remains important, for they remind us that wormholes are not fantasy, but natural solutions hidden within Einstein's equations. The problem is not in the math. It is in the stability. If exotic matter could exist, if negative energy could be placed at the throat of the wormhole, then perhaps the deadly black hole tunnel could be transformed from a collapsing shadow into a traversable bridge. And so the black hole becomes both a warning and a source of hope. It shows us the danger, but also points the way toward the possibility. Picture yourself now, drifting near a black hole. You see the stars bend around it, their light curving, caught in the gravity well. The blackness at the center is absolute, a circle of night that nothing can escape. It feels terrifying, and yet profoundly beautiful. For in that silence, in that darkness, lies the possibility of a wormhole. This is a paradox. Black holes are both the most destructive and the most imaginative objects in the universe. They end stars, but they open dreams. They crush, but they also inspire. Some theories even suggest that what we call a black hole in our universe could be a wormhole to another, that the matter falling in does not vanish, but emerges elsewhere, perhaps in a white hole, a theoretical opposite of the black hole, where matter is expelled instead of consumed. We do not yet know. Perhaps black holes are only prisons. Perhaps they are bridges. Perhaps they are both, depending on how we learn to see them. But what is certain is this: without black holes, we might never have discovered the idea of wormholes. They are the dark mirrors that reveal the light of possibility. So as you drift into rest tonight, let the thought comfort you that even in the deepest darkness, the universe hides doorways, that even in destruction, there is wonder, black holes and wormholes, two faces of the same cosmic mystery, the shadow and the bridge, the silence and the dream. Close your eyes, dear listener, and picture the universe as wide and endless as it feels, stretching in all directions, filled with stars and galaxies, each one a glowing lantern in the cosmic sea. Now imagine, hidden within this grand tapestry, a secret doorway, a tunnel that leads not across roads or rivers, but across galaxies and perhaps across time itself. This is the wonder of wormholes. For even if we cannot yet build them, even if we never step through one, their very possibility expands our imagination. Think of how many times in history the impossible became real. Once, people believed we could never fly. Then came wings of metal, and planes carried us across oceans. Once, people believed we could never touch the stars. Then rockets carried astronauts beyond Earth, into the stillness of space. So, too, wormholes remind us that today's dream could be tomorrow's discovery. They whisper pathways we cannot yet build, but which our minds are already learning to see. The wonder of possibility is this. Even if wormholes never become highways for us, they still stretch the boundaries of our thought. They remind us that the universe is far larger, far stranger, and far more generous than we can ever imagine. Let us think of possibility not as a fact, but as a gift. The gift of asking, what if there are tunnels in space-time, waiting quietly for us to discover them? What if other beings, far away, have already found them and wander between galaxies as easily as we cross a street? What if wormholes are not merely science, but bridges of destiny, linking civilizations, linking hearts, linking the past and the future? Perhaps none of this is real. Perhaps it is only a story. But stories, too, have power. They shape the way we see the world. They invite us to explore, to push against the edges of what is known. And when we think of wormholes, we are reminded to keep dreaming, to stay curious, to never believe that the universe is too small, or that its mysteries are finished. The gentle wonder of possibility is that it softens us. It gives us comfort to know that beyond our daily lives, beyond our routines, there is always more to discover. As you rest tonight, let this wonder cradle you, like a lullaby sung by the cosmos, soft, endless, and kind. Now, dear listener, we reach the final step of our journey together. Through wormholes and black holes, through space-time and exotic matter, through science and imagination alike. What lies inside a wormhole? The truth is, we do not yet know. Perhaps nothing at all. Perhaps everything we can dream of. But what matters is not only the answer, it is the question. It is the way that asking draws us deeper into the mystery of existence. When we gaze at the night sky, we see stars. But with the idea of wormholes, we also see possibilities, doorways, adventures waiting in silence. So tonight, let this thought be your blanket, that the universe is not closed, but open, that every horizon may hide another path, that even in the quiet of sleep, the cosmos whispers of journeys yet to come. Rest peacefully, my friend. May your dreams be gentle, your heart be light, and your spirit filled with curiosity. Good night and goodbye until we meet again among the stars.